So today I'll be speaking about multi-agent systems at scale. Actually, this is a very high-level talk. I'll give some examples of the stuff we do, but I'll also talk a lot about agents and AI in general. I think there's a lot of ground to cover, but I'll try and keep it as concise as possible so you can ask questions at the end if you want. Name's Kristian. I'm an R&D engineer here at Manychat. And prior to that, and well, currently, I'm also an AI product engineer. I like to call myself an early agentic AI pioneer because I started working on agents like way back. And previously, I used to be a founder in the computer vision space, but I really like language models, and I was always so fascinated with them, so it just sort of naturally just came to this. Manychat is, as hopefully all of you know, the leading chat marketing platform. We enable businesses to drive more sales and conversations and automate conversations with their users. And we do that through messaging apps. Manychat is obviously really, really huge in terms of the volume of the stuff that we process. Yeah, that's actually 1 billion, more than 1 billion messages per month. So those are super high volumes. And this means that when we work with such high volumes, all the stuff that we do with AI has a lot of potential upside. So that's exciting. The goals of today's talk really are to understand and appreciate agentic AI and what it can do, and obviously all the different obstacles along the way. Also, to cover a little bit, well, a few application strategies of AI systems. And the most exciting part, for me at least, is about the vision and where it's going next and what the future will hold. So, just to give a brief overview, I think this is super important because really a lot of the stuff extrapolates from this, and it's about how LLMs came into play and what they're good at, because essentially we're building with these blocks, even if we look at agentic or workflows. It's all the same thing at the end of the day, just a different complexity. So classic LLMs is what you guys are used to using. Hopefully, well, you've experienced ChatGPT obviously in the early days and played around with some role play maybe. So these are all about zero-shotting. So you have an A and B system where A is the user message and it's like a partial prompt. And then you have a static component to it. And then the LLM basically just responds. And obviously this is awesome because this is where all the hype came from for AI, right? We got some of the first foundational models and they were so cool. We could do so many things with that. And we started to think about, okay, wow, we can really bring value or at least have fun with this. But because of this system, there's a lot of inherent limitation because we're literally zero-shotting the prompt. And well, there's nothing you can do in the middle in that process. It's all like chaos, right? Statistics, it's literally random. So that's where, we came onto chaining, or otherwise called workflows. So this is pretty much just the first scenario, the classical LLMs, but they're stacked next to each other with very separated concerns. Well, some LLMs maybe are better at interpreting context, right? And then using that context in another call to generate a response. So essentially what this allowed us to do is to have program logic interact with the way LLMs generate content. And this is a very important step forward. So, for example, a lot of you might be familiar with Perplexity Research, where some of the different tools you can use and some of those apps, those are all pretty much workflows, although some of them have evolved beyond that, but I'll touch on that a little bit later. And there's a lot of popular frameworks you can use. Surely everybody heard about LangChain or Llama Index and played around with them a little bit at least to see how workflows can be set up. But this translation of program logic and being able to kind of have trees of decisions of different linear paths towards a particular goal, or maybe even branch out to different goals depending on what the user is coming with, has given us the building blocks that we need to build LLM agents themselves. So LLM agents, well, I'll call them agents, pretty much just the same thing as workflows, but there is one important distinction here, is that they're capable of, well, they're designed to create conclusions in the middle of a process, and then use those conclusions to drive other actions, all in kind of one, in the span of solving a particular goal for a user. So, and the way this would work is you would have the user message come in, obviously, as the A section, and then it would drop into agents, and we could do stuff like, first we can focus on understanding intent, and then we can focus on getting the right context, and then we can focus on solving the goal, and do that all inside this cycle, and present the user with a reasonable answer that the agent system actually thinks is reasonable. And so the main distinction here is the agentic loop, right? Because it's capable of doing these operations in sequence, of constantly making itself better, hopefully. It doesn't always go that way, but it's able to perceive, reason, act. It's also sometimes able to learn, and basically collaborate with other things in the system that are available at runtime. So that could be other agents or tools. This is all really pretty much solved now. There are agentic frameworks and systems in place that are commercially viable and people are using them. But there is a future to this as well. And I think it's very important to have an outlook on where we're taking this, because it might appear from first glance, from what I'm saying, is that we solve this, right? We can solve a goal for a user, but the problem is that we want to go further than that by being creative and having agentic systems that actually innovate in the process. Solve use cases that are not identifiable at any given point. So you can have users come in with a particular use case, and future agentic frameworks should be able to kind of work with that, not fail, right? And that's where a lot of that's where the future is going with this, and I'll talk about it a little bit as well in the vision part. So LLM agents are not just cool because they do stuff and can interact in a single process and call tools and save context or operate with various functions, but it's also the nature of the flow itself, the way agents are composed, that creates a superior outcome. So if we look at this rather dated and actually quite old graph from 2 years ago almost, this is by Andrew Ang, and it's from a paper on human eval, which is benchmarking. It's a benchmark you probably seen before. But the reason I included this is just to show how capable, how agentic flows or agentic systems actually reinforce and multiply the effect of a foundational model. So here we have the GPT 3.5, zero-shotting, and then GPT-4, which is the classic approach, right? So it just gets a user message and makes a response. And what's interesting here is that GPT 3.5, even though you can't even use it anymore most of the time, it's better than GPT-4 in a lot of agentic, pretty much all of them, all of the agentic applications in this paper. So agentic frameworks, agentic AI is pretty much a multiplier on top of the foundational model as well, which is really important to consider if we're trying to do very elaborate and sophisticated actions or solve goals which are particularly complex. However, there are significant challenges with agentic AI, and a lot of people fall into traps building agentic AI. The primary concern when we're building agents, making these autonomous systems that can sort of iterate, loop on themselves, is that complexity grows incredibly fast. Because every single element is actually not just a linear element. They can be called ad hoc by the model, right? And the effects can be unpredictable. And we actually get a lot of emergent behavior, which can be good and also really bad at times. Additionally, we're used to prompting, but prompting is such an art. I'm sure, like, if you've been doing AI apps or anything, prompting is a big pain, right? And when you're talking about agents and you have agents that interact with agents, all those prompts create these very subtle things that are really hard to track. Like one word change or one phrase change can really impact everything else in the system. So it becomes really brittle. Additionally, costs are pretty extreme if you let agents do their job, and sometimes you just have to, because otherwise they don't really give you a good result. But if you're using state-of-the-art models like Claude Opus, it can really balloon. I'm sure you guys seen some of the Twitter posts about Cursor and people getting charged like $8,000 per month, right? So this is like one of the drawbacks. But they're lucky because they outsource that drawback to the users. Additional thing is that inference obviously increases, right? Because you can't really apply agents in the same way in some apps because people just won't wait for them. You have to do very weird things, like you have to send push notifications. There's a lot of product considerations when working with Agentic AI. And yeah, just to speak to my previous points with state-of-the-art models. This is another cool, this is a cool paper I found recently. It's actually from March this year, but it demonstrates a very significant problem that a lot of people kind of don't really care about much, but it's about adversity and it's about opposition. So if you have agentic systems that interact with each other, what you can have is you can have behavior that opposes the actual behavior that you want to or expect to see. So if you have, let's say, one big agent that's working on, I don't know, one particular task of booking a person into a flight, and then you have one agent working on booking a person into a taxi, let's say. This is a bad example. But they will conflict with each other, right? And all these behaviors are super hard to track. And if you're building an agent that has a lot of tools, good luck kind of breaking it down and finding how to make it work. And actually in Manychat, one of the first experiments we did with agents, we kind of fell into this trap where we tried to have one agentic system do everything. And what happened was we couldn't, like, it worked, but sometimes it didn't, and we couldn't really understand or track and actually reason on how to fix problems that caused the behavior to become erratic or chaotic, unpredictable. So we had to scrap that. And yeah, but this all sounded really bad, like it's impossible to do, but really it's very possible today. And the way Agentic AI can be set up is actually by just sticking to simple things, you know, building simple. A lot of product managers try to build products like that, you know, constantly asking you to just build a prototype. Well, here it works the same way. So we have to build single agent workflows before multi-agent systems and sort of chain them together. This is the best approach because it allows us to constrain agents to work in a particular and highly defined domain of action. So you would have one agent that's, hold on, I have a section about this. Yeah, it's a bit later. You can also, at the start, use human in the loop. This is a very good approach. It's hard to set up, but it's very useful. For example, if you have contacts and you have to verify that some parser system, you know, obtained the right information about a particular contact or address or something, human in the loop can really help kind of build that experience and understanding of the data and context. And once you have all those very constrained use cases set up, that's when we can actually expand into autonomy. And together with good observability, this is actually something that we can, you know, maintain in the long run, which is the big hurdle with Agentic AI. So modular reasoning, when we have agents that are set up correctly, results in scalable agent systems. And I will give an example. So, for example, you have a product expert agent, right? Something that has tools that can access product database or go to documents, right? Documentation for a particular business, let's say, and can decide what info to retrieve. And then you can have recommendations from that. And you can have an order management agent that has access to CRM, order systems, shipping APIs, stuff like that. Very, very concise in terms of how they're applied. And you can have billing agents as well that can do, like, you know, chargebacks and bill people, things like that. And we can build all those components as separate components, track them separately, have separate prompts and all that, and they're completely separate components in a system that acts as a whole, as a bigger thing, right, than the individual parts. And the way to actually make it work, if you have those components, right, we have this question, okay, so if we have this separation of concerns, how do we actually have this whole work together? And one of the good things that really helps is having a gateway. And the gateway is basically an agent that kind of understands the state and understands the entire system at any point of time. So when the user message comes in, it's able to kind of route the user request into an agent which is the most suitable for a particular use case that the person is coming through in the product. And then all the agents can iteratively work together. If they fail, they can tell the gateway that they're failing, that it's not really the use case that the user is coming for. And in an ideal case scenario, what this will result in is basically just longer inference times for the user. But they shouldn't be able to see that things are falling apart. The gateway is the orchestrator and also the filter. This is the most exciting part for me personally, because I like to think about this all the time. But it's about where we're headed, and it's about future of agents. At the end of the day, no matter how well we compose the agents, we always hit a ceiling. And this ceiling has been moving quite rapidly upwards because a lot of money is going into this, right? It's about compute, about how to decrease inference costs and make inference faster. And that's basically the driving force for agents. All of this would be impossible and would fall apart if not for great models that we're seeing today. So models like Gemini 2.5 Flash recently come out. Llama 3.2 series, my personal favorite. They're better, faster. They really don't require a lot of money to run. They can be easily tuned because obviously they're smaller parameter. And if we look at the example previously that I mentioned, individual smaller models can really kind of leapfrog over state-of-the-art models if set up correctly. There's a lot of models coming out. NVIDIA is training models in particular for agentic action and chain of thought. And we are seeing increased context windows that make RAG obsolete, for example, but also allow agents to operate with very large context when necessary at low cost as well. So future of agents is basically driven by the foundation, and the foundation is always going forward, and we can expect very, very good models next year for sure, much better than what we have today. And this is just a thing that kind of goes further than that, and we should think about when we're building agents, what are the agents going to be like as a premise in a year or two and in a decade? And this is something Sam Altman said once, actually many times, at pretty much all of his podcasts and stuff, is that we're pretty much done with chatbots, reasoners, and agents. Right? Agents are, if you do them correctly, you can set them up. But we're really not done with innovators, and full organization is kind of sci-fi at this point, but innovators is where it's at next. And innovators really are a challenge because they make us think very creatively. The agents, they solve what the user is asking for, and that's not always what the user actually wants. But the innovators, they're actually about solving what the user wants or needs at any given point. And it's not just about the logic of how we set it up, the system. Well, actually it is, but it's not so much about, there's no magic to this, really. It's about having the agents increase their core capabilities into proactive understanding of the user at any given point, proactive understanding of the issue. So if the user is coming to you with a support question, he might be thinking that it's a support question, but really we can sell him stuff, stuff like that. So it's about having the agents act as creative entities, or like human agents would act in a certain context. And it's about knowledge synthesis. It's really all about context and working super well with it, grooming it and housekeeping. Why I'm saying this is that when you're building agents, context is like the #1 thing. If you have bad context, everything falls apart. So whenever you're setting up an agentic system, like one of the first questions you should ask yourself, well, I certainly ask myself every time, is what should we have in the context? What are the parameters? What information can we get? Can we interface with user calendar, email, or something like that, for example, right? I'm just giving examples right now. But it's about systems that learn from your environment and not waiting for you to tell what's important. And obviously all of this builds into emergent behavior, because we like emergent behavior, because LLMs are all about it. You do stuff, and then it makes these wow moments, and that's what really creates the hype in AI. So that's it for the slides. Yeah, this is a closing remark that 2025 is still strongly about agents. I actually wrote this slide in 2024, but yeah, we're still there. Thanks for listening. I'm ready for any questions you guys might have, and I'm just going to leave another slide with my QR in case anyone wants to kind of connect on LinkedIn. Thanks.